So, welcome everyone. I do encourage you to ask questions, or even if you have comments, try to come up to the mic and interact. I've given this presentation a couple of times already, and I'm gathering feedback and new ideas. So I'm already working on a version 2 of this presentation for next year, because folks have been very enthusiastic to to come up with even more suggestions for C++ myths that we can chat about. And speaking of chat and the all popular Twitter these days, the C++ community is very large, and it's quite vocal sometimes when it comes to controversial issues, and we like to have opinions, strong opinions, and have debates on various, sometimes insignificant topics. And we might fail to see the big picture. And I think the problem is that we're very fragmented on many of the topics that we talk about. We're fragmented based on the breadth of the C++ ecosystem. There are so many industries and niches and interests and domains where C++ is used. And we each bring our background and our experience to this conversation from what we work with or from our past experience. And I think that's okay. And I'm going to reference Bjarne's elephant metaphor there, but in a different shape. Apologies to the vegans in the room, but this is my take on it. So we each see a different part of C++, and we care about certain features or certain goals about our programming language, and we feel the need to impose those opinions upon the whole community. And there's a lot of good sources of information out there. There's the almost standard CppCoreGuidelines. There are plenty of best practices out there, some of them quite opinionated. There are established idioms that most of us follow. There are books. Yes, books are still a thing. There are very nice conference presentations, and of course, there's Stack Overflow. And you are going to see a lot of very interesting takes on some of the subjects. So sometimes I think it's difficult to distinguish between serious debate or foundational arguments versus just plain gags or fun stuff. And I'm guilty of some of that myself. And mixed up in all of this, there's also plenty of myths. And some of them stem from obsolete information that's still out there, not just books, but articles and even Stack Overflow answers that are deprecated by today's standards. And there's plenty of bad teaching materials. Yes, I've seen plenty of those. And speaking of teaching, this is something that's very important to me. I often do guest lectures at my alma mater and other universities where they invite me to do a workshop or present something. I'm doing one in a couple of weeks. And I care a lot about how we teach C++ as a beginner language, what are the intro courses for C++, and how we approach bringing new folks into this community in the C++ ecosystem. And some of the items that you might see here today might feel silly or might feel trivial, but I do constantly hear them when I talk to students, when I talk to interns, and folks joining this C++ ecosystem. If you want some of my takes about teaching C++ in 101 courses and algorithms, I have a short presentation from ACCU last year. Speaking of Stack Overflow as a source of truth and learning, I think we've all seen threads like this one, where someone may come in without much experience and really desperate to understand stuff, and they encounter people that are less friendly, let's say, and try to be the good gatekeepers of this community by pretending that everyone should have the same experience and knowledge as they do. So let's try to be a more welcoming community. Let's try to remember that each of us have been in a situation where we learn something new and we need help. So let's be more helpful. How this thing started, so the motivation was a couple of months ago. Oh, more than a couple of months ago now. Time flies when you're having fun during the pandemic. So some time ago, I had a chat with Jason about some of these topics, and we said we're going to do a stream together. It's a very long video. I don't really recommend that you go through all of it. It's more than 2 hours. And we just riffed. We said we're going to do an improv session. I gathered some of the topics that I've heard frequently, and we did a kind of a list of things that we want to talk about, but the whole session was completely improvised, where we tried to write code and discuss some of the things that we cared about. And it was quite popular. Last I looked, it had over 20,000 views. And the reason I want to give this talk, and I've done it a couple of times now, is that I try to instigate a healthy dialogue around some of the subjects and others. And I want to encourage people to feel comfortable raising questions about maybe things that some consider trivial or already known or solved. But I want to encourage people to feel comfortable to talk about them and raise these questions. And I want to encourage others to be helpful. So just to set up the game, as expected, I'm going to try to put some tags on the items, like confirmed or busted. And of course, we all know the staple response for programmers: it depends. So let's test this before we get started. IO streams are slow. That was just to confirm it. Not really a myth. C++20 modules will solve all of C++'s problems. We all hoped it would, but no. And coroutines actually shipped in C++20. I would say that's highly questionable without proper library support. We've already seen 2 good presentations at this conference on coroutines. If you missed them, I encourage you to catch them on YouTube later. And I think I've seen over 10, maybe more, presentations on coroutines so far, and I'm still learning. I'm still trying to wrap my head around what we need to do and go beyond trivial examples and Fibonacci generators. I really love this, this slide from Kevlin Henney. This is from a few months back at C++ on C. I chuckled so hard when I was in the room for this one. I think it really captures what we got there. Okay, so I think you got it, how it works. So like I said, this is part 1 of this series. I intend to do more, and I encourage other speakers to join in the bandwagon and maybe roll their own. I think the older folks in the room might remember times where Stack Overflow and forums were not such a popular thing, where we used to reference item numbers from Scott Meyer's books, like item 14, item 21, in code reviews and in discussions. And we even had a Guru of the Week series where we had interesting idioms or gotchas. So I like the numbering scheme, and I'm trying to emulate that. So let's dig in. First one, printf and the family of related functions are very fast. And this usually comes in the context of people trying to stay clear of IO streams because they know those are slow and have their problems. And they think the printf family of functions are the better alternative. And when you set the bar that low, yes, they're better. But they come with their own issues. And not all, as opposed to IO streams, my experience in talking with folks is that not everyone understands the problems related to printf family of functions. And I have a case study here. So for sprintf, it uses the global locale, and it acquires a mutex lock to access it. So as we already know that mutexes are bottlenecks. On macOS, sprintf, which is part of system libraries, ends up spending almost all of its time inside the related mutex lock. So there's a link there to a short case study on Blender where they replaced sprintf with lib format, and they got almost 4x speed up on Mac and around 20% speed up on Windows. And I think it's worth reading. And the takeaway would be here that we have good replacements now. We have C++ 20 format and 23 print, and even if we're not there with our code base, there is lib format, which is easily incorporated and easily used in any code base. So I do recommend to go for the safer alternatives. And in general, I think this opens up a broader discussion around functions that actually use locale underneath. Because I feel that documentation sometimes fails to highlight this aspect. And we might not always want or consider acceptable the performance implications of this. So we need to be aware. Just recently, another locale issue, long-standing locale issue, has been fixed in Microsoft STL. I have here just the person that reported it and small snippet of the guilty code block. No need to study the details, that's not important. What I'm trying to raise awareness is that you should really look into the functions you're using for formatting and make sure you benchmark and you consider them appropriate for your particular use case. And see if your standard library implementation or your system libraries that deliver those C functions actually do the right thing and they don't exhibit performance issues. Moving on tooling, I think our species always depending on tools, and we've been on a constant thousands of years pursuit of building better and better tools for each of our use cases. And this applies to our younger discipline of building software programs. So we're always in the search for better tools. We always complain that our current tools are not good enough for what we need them to do. And I care a lot about this. And one of the things we keep hearing is that C++ is not easily toolable. We like to compare ourselves with other programming communities and reference their magical tool chains and their refactoring capabilities and their all-powerful build systems, their package managers, and so on. And I care about this because I've spent almost in all my 20-year career building tools, building developer tools. I spent a lot of time building some of these tools. And I recently joined Microsoft to actually help improve the tools I've been using all this time. That's because I care about how we use our tools and about the developer workflows and how to ease them. just recently, I wanted to highlight one of Jason's C++ weekly videos, and I very much liked the takeaway there that we are in a golden age of C++ tools. And I just wanted to capture some of the things Jason listed there. It's not a comprehensive list, but I think it's a good starter list. And I'm sure not everyone is well aware of everything in that list. I put links there, so it's easily to, you don't have to squint to see the small text there. The problem with the tooling ecosystem in C++ is that there are too many tools. We don't have a one true build system. We don't have a one true package manager, or we don't have the reference compiler or the reference library. We have many implementations. We have testing tools, profilers, debuggers, and we have, for pretty much any workflow you can imagine, we have a few alternatives. And some of them are known, some of them are not well known, and I think this is where we should do a better job of advertising this diversity and getting to know the tools and be more experimental in our approach. Be willing to try a new tool that we haven't heard about. Maybe I'm hearing of Dr. Memory for the first time. Let's see what that's about. Let's see if that tool is better than what I'm using. Let's see if it can help in my project and in my team. So we should be more experimental, more willing to try new things and learn about this set of tools. So the problem for C++ is not the lack of tools. I think the problem is that we have too many of them, and we need to get better at learning how to use them. And no matter if we're talking about a static analyzer or sanitizers or refactoring tools or build systems, whatever the tool might be, what we need to do is try out to see what fits for our projects and our needs and what's most ergonomic for our workflows, and get to really know how to master that tool. I think that's important. I think the problem is some tools have maybe a difficult learning curve, so we need to invest a bit more time to get to understand how to use them. They may lack proper documentation or examples, but if we feel that we might gain insights into how our programs work, or if they might help us in our daily workflows, we need to invest time to learn those tools, to learn all the switches, to learn how they work, to discover their quirks and report bugs, or to help out, improve them if we can. And I think that it's worth pursuing mastering the tools that we think might help us. Let's move to the other one. Standard regex is too slow for production use. This is actually slightly embarrassing. Jason and I, when we did the live stream, we spent, I think, around 10 minutes trying to write this piece of code. Yes, it's embarrassing and it's on video. And the reason is that we didn't know how the API works by heart. We had to look it up on CPP reference to see, okay, what do we need to pass here? It actually is so slow to compile. It actually times out Compiler Explorer. So if you know Jason, he used Compiler Explorer to mock things up, and we had constant problems there. And I say it's slightly embarrassing that we were not able to figure out how to use this API. So for sure, at least for us, it doesn't feel intuitive to use. And it's a trivial example. We were trying to parse something like a key value pair, some sort of config file. So it wasn't a complicated task at hand. And it comes with many gotchas. So for sure, we had difficulties, and we constantly need to check our assumptions about a particular function or a constructor in the API. And it was slow to compile, of course. It was very slow at runtime as well. And even for simple examples, we need to be careful about the performance gotchas. We need to be careful about the regex constructor, about the CMatch expressions we're using, and where we place them in the program. Just make sure they're not on the hot paths, and we don't completely tank our performance for no good reason. So for better or worse, this is what we have in the standard, but we're not forced to use this all the time. So I would urge you to consider the alternative and use any regex library that you feel comfortable with or you have experience with. I do recommend this one, CDRE, which is very fast to compile. It has a much cleaner API, and I feel it's intuitive to use even without checking the documentation too much or the other examples. It does support string view, and it builds regular expressions at compile time. I put the link there, and just a show of hands quickly. Who is already aware of CTRE, even if you're not using it? Okay, I would say that's more than half of the room. That's good news. Now start using it. Okay, and we do have Hannah here in the room, by the way. And you can ask her questions if you want, or even say thank you. So moving on. I talked yesterday about standard optional quite a bit, but let's see it from a different perspective now. I've heard this more than a couple of times, and it always annoys me a bit. Standard optional inhibits optimizations and complicates APIs. And let's break it down. Let's analyze the performance implications first. Again, I took a very simple example here. We have a getSize function that in turn calls a value retriever function, getValue, which might yield or not an optional string based on some condition. So this is the simplest thing that we can do with something that might or might not yield a value. That's why we might use an optional, right? And if we look at this, we already see, if we're inspecting the assembler code there, we already see that somehow the compiler figured out the result already. So the length that we requested is 5, and it somehow saw through everything. So we didn't get an explicit call to get value from as the code states on the left. And if we squint really hard, we can even see the bits of magic in how compilers lay out code. And we have our literal string right there. So the compiler pretty much sees through all of this. We don't have any direct function calls, or we don't pay any abstraction penalty by using this optional indirection here. But you might say this is it was a trivial example. It was a short string in a literal. So even if we go for a longer string and we force the compiler to go to the heap, and it's no longer able to use small string optimization there, we see the allocation there. But again, the compiler is smart enough to see through all of this and figure out the length of the string easily, 23 at the bottom there. So in situations like this, I think this is not a complicated task for any of the compilers that we're using. But, there is a but. Standard optional comes with some performance gotchas. So I did a small change over there. I'm not sure if you noticed the change from the previous slide. I basically hoisted the content of the string into a standard string variable now. So it's no longer previously, let me go back, maybe it helps. So previously it was directly returned, and now I hoisted it in the standard string. So superficially, this seems like a harmless transformation. And even for a more complicated example, we might fail to see when we do changes like this. We might fail to see, maybe if the function is more complicated and it has more return paths, or we return different things from the function, it's very easy to fall into this kind of trap. And I do see this in real code. So it's not I don't think it's an exaggerated worry. And it's a silent thing. And if we analyze the implication, we immediately see that compiler has to do a bunch more work here. I have a side-by-side diff, but that's not important. It's considerably more work. And the reason is that we are now forcing the compiler to do a copy constructing of the string. So because we have a mismatch. Our function expects to return an optional string, and we are giving it a string to return. And it just works. And the problem is this constructor for optional, which constructs an optional object that contains a value initialized as if direct initializing an object of type T from the value. So this is intended by design because it eases using optionals. But it comes with performance gotchas in some situations. So we need to be aware when we need to be careful to match what we're returning from functions and not fall into performance traps like this one. Oh, going the wrong direction. Sorry about that. And now the other part of the story. Standard optional complicates APIs. And this is where I spent a bunch of time yesterday when I talked about boxes and lifting and other functional programming idioms. And the idea here is that I said optional is like a box, and we wrap a potential value with its context, and we shouldn't really peek into the box and try to check the value at each step of our processing. If possible, we should try to avoid using optional for error handling. There are better ways to do error handling, including expected now. By the way, there's an expected presentation at this conference. I think it's the next time slot after this by Ivan. When in doubt, draw inspiration from other APIs. If you're not unsure on best practice to compose things like this. If you know or you're comfortable with other programming languages which have been using this for a while, much longer than C++, do try to draw inspiration from those. And the idea is to use higher level functions and try to construct processing pipelines out of optionals and chain operations together without checking at each step to see if we yielded a value or not. The idea is to be goal-oriented rather than involved in the mechanics of moving the enclosed value there. I do link to an interesting mini-series of articles here about some functional programming techniques and things that should feel comfortable to everyone, even in C++, with concepts like application and fmap. because we use these kinds of things, even if you're not aware of them. This is not a high prerequisite material, doesn't require any formal math knowledge or category theory or anything. I think it's a very intuitive series, and it really helps with pictures, nice pictures. So don't try to look inside the box. Don't try to if-else around optionals to see if we have a value, and do branching and decision and control flow based on whether you have values inside or not. And don't try to extract it until it's really necessary. Try to be lazy about it. Take it at the end of the pipelines. So I did talk yesterday about boxes and lifting. Very briefly, we need to use higher order functions to change the domain and codomain of our functions from A to B to optional A and optional B. So we need to use techniques like fmap to do such a thing. I'm not going to go into details about them now, because I presented them in length yesterday. And you can catch a version of that presentation from CppCon or from this conference when it comes online later. So I won't go into too much detail now. Very brief example. Let's say we want to transform a string representation of a number into a number. And of course, this might be an operation that might fail. And don't worry about the details, the mechanics of the transformation using from chars there. I do care about the chain of operations that we're doing. And I want to point out the way this code is structured. Rather than being a highly nested series of if-else or inversion of control or any weird callbacks, the idea is to strive for something that feels sequential in nature, feels linear, like steps in a pipeline. And we see here hints of our monadic continuations for standard optionals that we got in C++23. And don't worry, even if you're not on a toolchain that supports this already, there are quite a few implementations out there, header-only implementations that you can easily adopt. The one I would recommend if you need to use a third-party implementation is the one by Cybrand. Just look for Tartan Llama on GitHub, and you're going to find TL optional. So look at the and-then continuation. Look at transform there. I try to pick up something that sounds reasonable in a real-world scenario. Don't care too much about what we do in each of the transformations. It's not that important. Just appreciate the nature of building things like this in a sequential fashion, as opposed to having a bunch of if-else in a longer function. And at the very end, we actually open the box with the value function. You see at the bottom there, to see if our processing yielded a real number or not. So I think if we learn about the good idioms in using things like optional, if we're trying to leverage the experience other programming communities already have around such concepts, folks that are familiar with Rust or other programming languages which have been using this for a while might appreciate this more. But I do encourage everyone to steal from other communities that have more experience. Look at their APIs. Look at how they build libraries using such facilities. And try to see if we can do the same in C++ now. Moving on. We have a good tradition in C++ over time to give really good names to our functions. Think about empty, size, length, and other good names we come up with for our standard library. Standard move doesn't move. Standard forward doesn't forward. standard remove doesn't remove, and standard function is not really a function. And I'm going to pick on one that I hear often, surprisingly even from folks that give presentations on stages like this. So standard move does not move. And I'm going to start with a simple example. I have a simple echo function that takes two strings by const ref and prints them. And I pass in a standard string that I construct. Nothing fancy here. The expected result, no surprises so far, of course. And now let's try to move the greeting inside the first argument of the echo function. And this is where I hear gasps and weird expectations from folks learning C++ for the first time, or folks that are moving from older C++ to C++ 11. And they're surprised by the behavior. They expect that something happens when they call the move function there. And I've even seen stuff like this. Honest to God, I've seen it in code. And again, nothing happens. And the misconception here is that they expect that standard move actually does something every time, because they've seen it does something in other contexts. And what happens here is that standard move is just a fancy cast. And there are plenty of code bases out there, and I'm learning about more of them, especially in gaming, in game studios, and projects that are not using STL or newer C++ versions. They actually roll their own. They have macros for stuff like that. So it's not a novel thing. As a community, we've been using stuff like this for years. And standard move is just a fancy cast. And the reason this doesn't do anything is because a const string ref just binds to that R value ref that we're building there. So nothing really happens here. But if we make a slight change, an important one, and we modify the API to take strings by value, and I think this is where I've actually seen folks try to do parallels with how Rust borrow checker works and lifetimes. But for C++, this really changes things. And if we run the same piece of code, we see that one string got in and the other one didn't. And the reason why this now behaves differently is because now we're actually calling the move constructor for the string, because we changed the API for echo function, and we are now requesting that we invoke the move constructor for string. And this is what happens on Clang. On GCC is the other way around. And the reason is that we just have a different order of evaluating arguments there. But it doesn't matter. This silly example just moves on both arguments. But the idea is to understand that the move has a meaning in a particular context. Move by itself is not important. It really matters in what context are we moving. In what context are we trying to cast that reference to something that is movable from. So, of course, this one is busted. And sticking to the point of function arguments and our echo API, there always pass input arguments by const reference. Folks that have been doing C++ for a while know this well. It's one of the items in Scott Meyer's books, so it's a classic. And let's think about this a bit. Let's say we have two constructors for a widget class that stores some kind of ID inside, and we have these conversion constructors for constructing widgets. with some IDs. And this is the classic and surprising idiom of using two constructors, one by R-value and one by constref. I think most folks that are comfortable with C++11 have this imbued in how they work. But this idiom doesn't scale well. I think we're all aware of that. As soon as we have more than one such field that we need to construct from, we have a combinatorial problem. I don't think it's humane to ask for programmers to be able to write this without doing mistakes. But sometimes we have to. And there's a new pattern that we can use, relatively new, where in situations where we intend to take ownership of those variables, and we use the so-called sync pattern, where we actually take them by value, mind you. Be aware that the constructor takes them by value now, and it just syncs them in to the fields of the widget structure, just takes ownership of them. This is what is known as the sync pattern, in case you want to give it a name. Same thing applies for setters, so feel comfortable if you see something like this. Don't panic in code reviews. Don't run away. Try to understand. And again, we take ownership of that new thing. Again, folks coming from, or folks that have some experience with Rust and borrow checker and lifetimes, I think appreciate this more. Let's try to analyze it a bit in detail to understand what happens. Here I'm calling the setter function, giving it the string literal directly. And what we have to create the string, excuse me, with a string literal value. And then we do a move assignment into the data member, as instructed by the code. If we hoist the, the string literal into a standard string variable, sorry about that, slight difference. We have to create the string with the string literal value. We have to make a copy of the string now, as instructed by the API signature. And then we do a move assignment into the data member. So slight difference. If we do a standard move there, then we create the string with a literal value. We move construct the string, and we do a move assignment into the data member. Now, if we have the classic full-on overload set of setters for name, one by constref and one by R-value ref, then in our example there, where we have the standard string in a hoisted variable, we create the string with the literal value, and then we make a copy of the string, and that's it. And we fall onto the first overload of set name. So technically, this is more efficient because we have one less move operation than the case where we use the sync pattern. So in some situations, the sync pattern forces one extra move, and if move is expensive for your type, let's say maybe you're implementing something that has an internal buffer, something like small size optimization kind of thing, and move might be something that costs something, then the sync pattern is not the optimal way, even though it's more ergonomic. But you have to measure. And sometimes you do care about, for example, if you're doing repeated operations and you're trying to reuse a variable, you do care about the capacity, the allocated capacity. So this is affected by using things like the sync pattern. And sometimes you want to just take the value without resetting the capacity you already have, the memory you already have allocated when you're trying to do this in a repeated kind of fashion, let's say a for loop. So the sync pattern, I'm not claiming it's universally superior. I'm just claiming it's more ergonomic, and you shouldn't be afraid of using it or when you're seeing it in code reviews. There's even just want to raise awareness about this. There is even a client ID modernizer check to perform this transformation automatically and at scale. So it works very well. I've actually used it in large projects, and it's one of the checks that are high quality in terms of getting it right. Not all client ID checks are perfect. So you can play with it if you want to see effects in your code base. You can run it just as an experiment. Just run it through a project. It takes a couple of seconds, minutes, depending on the size of the project, and just examine the diff and be amazed. And maybe run some benchmarks. I hear that helps too. And if we're on the topic of C++ move semantics, we're almost proud of how complicated things are. And some of us make a good living out of explaining it. But I think here, even if when I learned Rust, I struggled constantly. I was in a constant battle with the compiler and the borrow checker because I just didn't get it coming from C++. But I think it's the superior way to go here. Rather than reading books or hearing presentations like this one, just having this baked in the compiler and not letting you shoot yourself in the foot, I think it brings an immense value to the table. And there are efforts in C++ for this as well. There are efforts at this moment to bring lifetime annotations to C++, to have hints in the code, somewhat similar to lifetime annotations in Rust, to help us catch these kind of things, whether they're lifetime issues or performance gotchas, to help us catch them while we compile. There's a big effort at Google around this thing, and in the Clang community in general. So everything is not all about successor languages. Another myth is about const. We hear that we should like const and use it everywhere. We hear that you should use const expr everywhere. And I just want to quickly raise awareness that in C++, const can come with some costs, with some performance gotchas. So const all the things is not always the right idea. We have to think about some of the anti-patterns. And again, I have to point to Jason here and highlight just a few situations where consting things will actually hurt you in terms of performance. Don't const non-reference return types. Don't const local values that will need to take advantage of move on return implicitly by the compiler. And be aware here that this might be even more complicated if you have multiple things you're returning from a function. So if your function is just something simple, it might be obvious. If you're building something more complicated and you're returning different kinds of things, you might miss it. Don't const non-trivial value parameters that you might need to return from the function. You have a parameter, and you are going to return it. Think the trivial example is like an identity function, something like that. Don't const any member data. And the theme here is that being eagerly enthusiastic to use const everywhere will actually inhibit move on return in many situations. So it will hurt the performance because it will inhibit compiler optimizations. So you need to be aware to stay away from these patterns. And if we're talking about const member data, I think most of the time it just doesn't make any sense. It breaks implicit and explicit moves. It breaks common use cases for assignment. And this is not the way to achieve immutable data structures, let me tell you. So don't const all the things. Think about it first. Should be a good first thought, but think about the consequence in some situations. Moving on to another one, make all data members private. This is typically seen as a good practice in object-oriented programming. Enforces encapsulation, all the good things. Object is in control of its internal state. But we need to think about what invariants we need to preserve for that type. Not all types do have invariants to enforce. We need to document those invariants and assumptions, and we need to construct APIs so that they're easy to use, and we offer the right contract for those APIs. So if the things we're building don't need to enforce and maintain some invariants or ensure a particular contract with the caller, don't just wrap everything in getters and setters like inertia, like a Java reflex. Think about the complexity you're adding. And I'm not talking just about boilerplate and functions that you need to sprinkle around. Don't add unnecessary complexity just because you might need it in the future. I might need to control how this setter works or how this getter synthesizes a property or something. If you don't need it now, don't do it. Because aside from writing simpler types, that they're simpler to use and simpler to document and simpler to refactor, also constructors. Don't just add constructors for your types if you don't use them. You might just need some braces there. So don't add constructors if they don't do actual work in constructing or helping constructing your types. And the idea here is that you're paying technical debt in advance. You're building something more complex than it needs to be without having a reason to do it. If there's a good reason, do it. Otherwise, don't do it just because of inertia or just because of everything needs to be an object and everything needs to be encapsulated reflexes that we've been taught into. Sometimes structs just want to be structs, you know. I do recommend this presentation by Kate Gregory, Abstraction Patterns. I think she presents some very, very good arguments in this regard in how we build abstractions in general in programs. The presentation is already online. I put the link there. I highly recommend that you see it. And yeah, sometimes structs just want to be structs. And if we're on the subject of structs, I have to recommend Mike Acton's talk. If you haven't seen it already, I think you should. I mean, like, drop everything. Just go away now and see it. It's well worth it. It's still unpopular opinion in C++ community, but I'm sticking to it. And I think it was one of the best C++ keynotes ever, although I still remember the audience gasped, and they knew who were they inviting at the conference to keynote, but I don't think they expected the result. But it's one of those talks that makes you think. And I think that's the point of a keynote, not to show you something fancy, something new, but to change, to shock you, to change your mindset, to reframe your context, to make you think about what you're doing. So it's all about data transformations, and software is about transforming data. And performance is all about smart data layout and thinking about memory access patterns for particular workflows and how you organize your data around those memory access patterns and squeezing every bit of performance, and about the vector of structs or structs of vectors, so how you explode your fields out of your OOP mindset and just consider an index in some parallel arrays as your entity you're traversing. So I think it's a well-provocative story there. And if you want a practical and more recent take on that, Andrew Kelly, the inventor and lead developer on the Zig programming language and compiler, actually had a very interesting talk, a practical guide to applying data-oriented design. And he very much channels Mike Acton. He even has the Hawaiian shirt there. And it's a story of using and adopting this mindset, this style of programming, and rewriting the Zig compiler in such a way and gaining tremendous performance. Another myth, iterators must go. When I first did this talk, I tried to do a Romanian accent and imitate Andrei, but it fell flat, because nobody knows I'm Romanian too. So there's a famous, this Iterators Must Go was a famous presentation that he did in 2009, and I recently was able to discover a recording of this, and I put it there. Really recommended and highly influential presentation for our community. So influential that Stepanov was pissed off by this presentation and said that Alexandrescu is on a crusade to eliminate iterators. And he had a very long rant about this in his programming conversations lectures at Amazon before he retired. So, this series of presentations is very high quality. I do recommend them. Well, somebody did properly destroy, not Stepanov, but after more than 12 years, and this was Barry Revzin. And I do consider this, there are a few flavors of this presentation, but I think this one is the most exhaustive one from CPPP 21, iterators and ranges. And Barry compares how iterators and ranges work in different programming languages with advantages and disadvantages and very, very compelling examples. So I highly recommend watching this presentation after you watch Andrei's. So yeah, iterators must go. Plausible. We do have ranges, but we still need iterators, in my opinion. Just watch Barry's presentation. He goes in plenty of detail there. And I'm going to close up with myth 0 there, or the foundational myth for C++, as I consider it, is that new C++, new things that come up in our language are usually considered the enemy of the old. I love this quote by Pablo Halpern. Before we had feature X, we were nonetheless able to program C++, so why do we need it? We constantly have to evaluate how we develop C++, how we learn about new features and gain experience with them, and not everything new is necessarily good or universally applicable. In general, they solve existing problems, but we need to gain experience with them. We need to learn where they're applicable, and not just blindly using them just because they're new and shiny. And at the same time, we don't have to be overly conservative in rejecting the new and just say, okay, I've been programming for 25 years like this. Why do I need, I don't know, optional or whatever? Or I have my own. Why do I need a standard one? Why is that better? So we need to think about embracing the new. I reiterate, I invite other speakers to join on this series if they have opinions or fresh takes. I'd recommend another one that I consider a sibling talk, Some Programming Myths Revisited by Patrice Roy. I very much enjoyed this one. I was in the audience at the time. This was an inspiration for me. Totally different things, different topics, even more challenging for the community. Very controversial stuff. Highly recommend it. And it's a lovely presentation. Watch out your sound level. Patrice tends to be loud. And in future episodes, some of the topics I do plan to cover, not binding contract, but I do plan to visit some of this stuff and even draw some parallels to famous successor languages there. So thank you, and I hope to have a nice chat with you folks on these topics. I think mostly offline. Okay?